Today we are treating the topic improper integrals, and we want to look at this important concept that we find under techniques of integration and other topics. So this is the integral sign running from A to B. We call this the lower end point. A is the lower end point, the B is the upper end point, or we can say A is the lower limit and B is the upper limit within the interval of integration. F of x is a function that we normally deal with. So we say our A, B is actually a closed interval. And because we are dealing with improper integrals, we want to explain what is meant by an improper integral. And so basically, we have these examples. And here the upper limit is in infinity. Over here, the lower limit is negative infinity, and then over here too, the lower limit is infinity, negative infinity. Now, if you look at all this and looking at the endpoints or the limits, one, or sometimes it can even be both, being infinity, and that defines an improper integral. Now, right now, we want to look at an example. So find the value of integral running from negative infinity to negative 1 x exponent x squared dx. So what we are going to do is that if we look at this carefully, we could see that if we differentiate this negative x squared, we shall get negative 2x. And so we will be able to introduce a 2 here and a half outside, where negative 2 and the negative half, then we'll be able to integrate, because that will be the answer straight away from the techniques of integration. So that's what has been done over here. So half, that is negative half, integral running from A to negative 1, negative 2x, now exponent negative x squared. So this multiplied by that will still bring us back here. Now let me also chip this in. The textbook I'm using for this lecture is Calculus by Dale Verbeek and Edwin Pessel. Dale Verbeek and Edwin Pessel, Calculus, the 7th edition. Right, so you can look for that book and then answer most of the questions. Right. And so when we come here, we've seen that the derivative of this is that. So right away, the integral will give us this. And so that's why we have this with our constant outside and within this interval. So here what we are going to do is that this is the upper limit, so we place it in, and when we square the negative 1, we still get 1, and this negative will affect it. So that's why we have this. And then that will be minus, so this will be plus. We slot in our A. Remember, because it's infinity, we put in our A here. Finally, we shall find the limit, and then we'll put it there. Okay, great. So we put in our A squared. Now the next step is that we now want to evaluate everything. So we find the limit as A approaches negative infinity. So where we have our A, place our negative infinity there. And because of the negative sign, 1 over 2 infinity also give us that. So basically this is 1 over 2 exponent, and this will be negative 1. So from indices we shall have it this way. So this will be the answer for that. Fantastic. So let me go to the beginning. I explained this, and these are examples of improper integrals. And then this is an example that we went through. It's an example that we went through. So look at it carefully. Then we did this one. We also went through this. Then we got this answer. Okay, so there are some exercises here. I want you to take your time and try them. So evaluate the following. So we have question 1. 1 over x raised to the power 4. Question 2. Question 3. So these are some questions that I want you to try your hands on. So that's the first part, the improper integrals. We shall continue at another time. Continue to revise it. try more questions and you make a headway. Thank you so very much and have a blessed day.